On this format, I visit various scrapyards, sifting through things others have thrown away. I'm always looking for high quality tools and equipment that is worth saving. Sometimes these items are not even in good shape, but I will try to do whatever it takes to bring these things back, for two reasons, even if the repair might seem somewhat uneconomical. One, I want to remind people what real quality manufacturing looks like, since it seems to vanish more and more from our daily lives. And two, the more complicated the repair, the more lessons are there to be learned. And if you play the long game, like me, you might understand that learning new skills, not hoarding expensive objects, is the safest investment in the future. With that in mind, let us see what we can find here today then. This pile of rebar here would be really useful for someone who had a major construction project on their hands, but that isn't me at the moment. Indeed, the scrapyards are filled with useful things. See all these stainless parts. There's a lot here that could be reused, but this is the kind of stuff I only buy when I have a concrete use for it. I'm not a professional reseller. One reason for that is that I live in a big city where space is extremely expensive. I just don't have the storage area to just sit on all these things. But look at this, it appears to be a high quality magnifying glass of some kind with a lot of potential for my workshop. No idea why you would throw this away, definitely buying this. This looks like a huge pulley, 8,000 pounds rating. Cool part, but you have to wonder if it's safe to operate if you found it on the scrap. Look at this though. The owner of this place has already put this aside because he saw that it was too good for the scrap, and I will take this home as well. This machine here has some really cool parts, but it is covered in absolutely disgusting lard and grime, and even though these are interesting parts, I guess I'll give this one a pass. I'm now inside one of the containers and I have to get out here really quickly because it's dangerous. So there wasn't much time to film, but see this item here, now that is something really cool that I will buy. And here's another old bench grinder and I will keep that as well. And also some of these aluminium parts here, because they will be needed to repair that grinder. So I'd say we have some pretty interesting items. Let's head to the workshop then and get to work. Let's have a look at this really massive and also really run-down looking power tool. And what is this anyway? Well, it is what is left of a massive two-handed power drill manufactured by the Fine Corporation. Fine are often credited as the inventors of the power drill, and unlike many other manufacturers, they offer a wide range of specialized, often rather expensive equipment of very high quality. Here's a modern version of this concept. However, Fine used to make these in different variations for decades. So let's see to it then that we get this one back on track. So while cleaning the drill from the outside, let us inspect for damage. A piece of this guard here in the back has broken off. That probably happened at the scrapyard. It looks severe, but other than potentially allowing objects to get into the fan and motor, it's not that much of a problem. These are the remains of some kind of drill stand that the machine was attached to. There is a cast iron rail sitting on the drill's housing, and the attachment sitting on that rail is clearly broken off, and we can remove that right away since I don't have any other parts of that drill stand. This is the power switch. I think it still works, but of course it only has two states, on and off, and no soft start. We will change that by adding a speed controller to this machine later in this video. And in order to replace all the old wires and to clean the switch, I will remove this entire box here from the orange main enclosure of the power drill. After checking the brushes, which are still okay, I'm opening the gearbox to take a look at the gears and the lubricant. This old grease looks pretty nasty and I'm cleaning it all out to be replaced in just a few minutes. I then also pull the entire rotor out of the stator pack to inspect the armature and commutator for damage, but can't find anything too unusual here as well. And I proceed by cleaning the fan sitting on the motor shaft, and then I also unscrew the drill stand attachment, clean the stator from the inside, and also apply new grease to the bearings. But before renewing the grease of the gearbox, I keep those parts separated for a little longer to remove the old paint by wire wheeling these parts. After that, Tape is used to cover those spots that can't stay as they are, while the rest of the enclosure receives a new paint job. For this, I did my best to choose an orange tone that comes close to the original fine orange. After the paint has dried for a few days, I apply new grease to the gears and into the gearbox, after which those parts are joined back together. And this is what the old on-off switch looks like from the inside. Two revolving pieces of brass that rotate between these copper spring contacts. Very rudimentary, but also very rugged. All this is just cleaned with some WD-40. It still works fine. A new power cord is also attached, and that entire attachment holding switch and wires is put back together. Now, our machine apparently had a drill stand or a similar attachment back in the day, but the fine documentation shows that machines like this could also be wielded as a two-handed drill, and that's why we will build a handle to fit into the thread that held the bolt fastening it to a drill stand. Measuring the outer diameter and the pitch of that bolt shows me that this is a 3/4 inch pipe thread. In my last video, I explored the possibility to build a speed controller for universal motors from salvaged parts. If you haven't seen that video, you should check it out. Links for that are down in the video description. See, I want to integrate a compact motor speed controller into this handle I want to build for this big power drill, and that's why I will have to build the entire handle from scratch. That job will start by cutting a 3/4 inch thread into a piece of steel. If only I had a thread cutter that could help me to do that. And, well, that is actually exactly what the strange green tool from the Scrapyard is good for. It is a thread cutting apparatus with exchangeable cutting dies or heads, apparently intended to cut threads into water pipes and the like. It was manufactured by the Swiss company GF, which also is still in business, or at least there still is a company maintaining these machines, and they were very helpful, sending me a very friendly email with a copy of the manual for this 54-year-old machine, and they did that free of charge, and within a day. Unbelievable. By the way, when I contact these companies, I always act like a normal customer, not even mentioning YouTube. So these guys are not friendly because they know that I have a bunch of subscribers or anything. They usually don't even know about that. Anyway, long story short, it turns out that this device had basically no damage whatsoever and simply needed some cleaning and was ready to go. So the plan was to cut a 3/4 inch thread into a piece of steel round bar. For that, I first cut off a piece with an angle grinder. It needs to have a certain length to fit into the thread cutter's centering vise. But the outer diameter of this round stock is still too large, and it has to be reduced to the OD of a 3/4 inch thread in my lathe. In order to fit into that threading die assembly of the thread cutter, the diameter of that bar had to be reduced on a length of at least 5 or 6 centimeters. With the 4 3/4 inch cutting heads installed, I simply had to turn that crank, even though it would have been easier had I properly fastened that cutter to the workbench. And this is what the thread looks like now. And in order to reduce the weight of this workpiece, some more work on the lathe was necessary. A center drill was inserted into the tailstock chuck, and we started to drill some material out of the inside of the handle. In its current setup, my lathe is not really suited though to drill holes much larger than this one into the bar to make room for the speed controller. That's why I decided to cut off the threaded part instead and then weld the thread to a piece of steel tube with an even larger diameter to have more room for the speed controller. I also used an angle grinder to cut a slot into that piece of pipe, because this is how we will insert the push button part of the speed controller into the handle. And now the thread part is TIG welded to that piece of steel pipe. The part that we are going to insert here was also shown in my last video. I bought it for around 80 cents on the German website Pollen, and it is an unfinished speed controller. It contains an on-off switch, as well as a plastic mechanism that turns a little trim pod when the button is pushed. The actual motor controller circuit is missing, and we will have to build that ourselves here as well. For that, one of these parts is equipped with a number of wires, leading to the switch and the trimmer potentiometer. They are then insulated with heat shrink and insulating tape. Now, what you see here is a motor speed controller salvaged from a vacuum cleaner. In my country, almost every vacuum cleaner has one of these simple phase angle control boards. Unfortunately, it is a little too big to fit inside the tube, and that is why we will have to build a similar circuit on a small piece of Vero board ourselves. And what I'm building here is really one of the simplest triac-based phase angle motor speed controllers out there, which has just a handful of components. If you want to understand these circuits a little better, I recommend you watch my last video, which covered this in part at least. Furthermore, I can assure you that this topic will be discussed in more detail in a future video, since I work a lot on these circuits at the moment. In the end, I wrapped the entire circuit board into several layers of insulating tape as well. The parts were then inserted into the steel pipe, and the remaining volume inside was completely filled with MS polymer adhesive, holding the parts in place and hopefully adding some more insulation. Just a word of warning. This is a live circuit inside a metal enclosure that has so far no connection to protective earth. And that is kind of dangerous if the insulation inside would fail. I don't recommend you to copy this design. After a few days, the MS polymer has sufficiently dried so that I can use a knife to remove any excess material. But how are drill bits actually connected to this power drill? Well, normally you would have drill bits that have a taper at the back end, in this case Morse taper 2. But unfortunately, I don't own any drill bits of that type. But what I do have is this drill chuck with a Morse taper that fits right into the machine. But before we drill something, let's test that speed controller. Now, this is a metal drill bit, but I will first test the machine on this piece of oak. Well, that worked quite well actually. Now let's try to prepare this piece of steel here, and I'm pre-drilling with a 6mm drill bit first. Now I'm drilling with a 14mm drill bit, and it does work alright, but I can tell you that it is very exhausting to put enough pressure onto the machine to get anywhere quickly. After that hole was finished, finally, I tried this again with a 20mm drill bit, and here it got almost impossible for me to apply enough pressure without hurting myself. As you can see, it does work, but for drilling holes this size, a drill stand might be a good idea after all. So, well, maybe I will have to build a drill stand and add yet another drill press to my collection in the coming months. Let's have a closer look at this rather strange looking device then. It's of course a desk lamp with a built-in magnifying glass. Or is it a workbench magnifying glass with a built-in lamp? Whatever you want to call it, it's clearly a piece of high quality manufacturing, and I think it could be very useful, especially in electronics work and maybe even for making close-up shots in my videos whenever I handle really small stuff. It was made by a company called Hensoldt from the city of Wetzlar, Germany. And where have I seen that before? That's right. Hensoldt Wetzlar builds optical and optronic systems for various armed forces. These are some binoculars of the German army. Like it or not, but that probably speaks for the fact that they are known for high quality equipment. This yellow button here probably needs to be pushed for 3 seconds, then released to start the lamp. The red button interrupts the current flow. And these push buttons were used to start and deactivate a fluorescent tube close to the magnifying glass. Unfortunately, the old wires were cut by the genius who brought this to a scrapyard. Upon removing the bottom plate, we can also find the ballast for the fluorescent tube. With the reflector removed, we can also take a look at the push buttons. After taking a look at the insides of this lamp, I decided to not restore the lamp to its original state, but rather convert it to LED. And I'm doing this the following way. I still had some of these LED strips left from my camper project. These strips already come with little current limiting resistors, and they can be connected to 12 volts DC directly without the need for further regulation of the current. They are also dirt cheap, by the way. I glued a number of them onto the old reflector and connected the plus and the minus poles of all the segments respectively, since they are intended to be operated in parallel. With resistors already integrated onto the strips, it doesn't really matter where exactly you connect them together, as long as you connect plus to plus and minus to minus. The reflector is then reinstalled into the lamp. I'm not going to reuse the old buttons, since they are not on-off switches in the classical sense. I will keep them in there because they look neat, though. The switch was manufactured by the Gainer Corporation. That would have been some decades ago, and my greetings go out to the viewers in the state of Connecticut, and especially in the town of Bridgeport, Connecticut. Anyone from there? Say hello in the comments. Instead of connecting the lamp directly to the grid, I will reuse this external 12-volt power supply though. I'm removing its old connector and attach it to the strange connector that came with the lamp. And in order to prevent further confusion, I even add a sticker to that jack. While working with the magnifying glass, it is rather handy if you're not only able to adjust the height and angle of the glass, but also the brightness of the lamp. When it's too bright, the glare can actually be a hindrance when reading the tiny letters and numbers on some electronic components, for example, and that's why I decided to add a dimmer circuit to this lamp. While there is a specialized integrated circuit for almost any job, it is sometimes better to have a number of go-to general-purpose circuits that can be used for a large range of applications. One of my favorite circuits of that type is a TL494 switch mode power supply controller. It costs a few cents and you can basically use it for almost anything that requires a pulse width modulation. DC to DC converters, switch mode power supplies, motor controllers, and as in this case, even dimmers. To understand the operation of the TL494 a little better, let me tell you this. While you can program a microcontroller in software, many older analog circuits can basically be programmed in hardware by calculating the correct resistor and capacitor values for just a handful of components. The circuit can generate a pulse width modulation with variable frequency and completely independent of that, variable duty cycle. It also has error amplifiers to regulate the duty cycle for constant voltage or current in a load under varying load and line conditions. It also has built-in transistors that can be used to drive mid-sized loads. I will not really go in details for the circuit in this video, but if you want to know more about its many applications, let me know in the comments and I might explain it in a future video dedicated to that topic specifically. For now, it is time for a practical test. And I must say I really like the looks of it, and I think it'll make a great addition to the electronics workbench. Let us see to it then that this old bench grinder is granted a new lease on life. It was manufactured by the Hafner Corporation. Founded in 1926, Hafner was one of the lesser-known German power tool manufacturers. As far as I know, they were best known for manufacturing high-quality routers and other woodworking equipment. Unfortunately, they ceased operations in 2011. It must have been very sad to say goodbye after 85 years. The best we can do is to keep their machines running as long as possible. While cleaning it from the outside, I can also assess the damage. The bottom plate is missing. The wiring also looks rather dodgy. The capacitor has a date code from October 1986. Not sure if this is the original cap though. From the looks of it, the machine might as well have been built in 1966. Imagine a world where things are not constantly redesigned, because they simply work the way they are. Under that crusty old insulation tape, we find a bunch of screw clamps. This black wire has gotten loose. But this is a rather easy fix, and I have connected a temporary power cord already. I later removed the screw clamps and soldered the wires together and insulated them with heat shrink. The tool rests are bent and need to be straightened. One of the grind wheels, as well as all the parts needed to fasten a wheel, are missing. So is the sidewall of the protective guard. In order to install a replacement wheel, I will have to machine some new parts on the lathe and also repair that guard. Before doing that, I want to look inside the motor though and see if it's even worth the hassle or if there is more hidden damage. Upon opening the motor, we can see that the stator winding and rotor are just fine. So are the ball bearings. Unlike the cheaper bench grinder I repaired in another episode, this grinder has no centrifugal switch. The capacitor is permanently connected to the motor. While those centrifugal switches might be common in other countries, they are rather rare here in Germany. Since there was no damage there, I put the enclosure back together. There still is a nut for the right-hand wheel, but none for the left. These bench grinders have one right turning and one left turning thread. This is necessary so that the two wheels on the opposite sides of the grinder can't come loose during operation. That's why the nut from the right side won't fit on the left. I measure the thread and I ordered a replacement nut. Here we can see the other parts needed to hold the wheel. There is a special washer on the outside, and then there are some plastic parts acting as adapters for the inner diameter of the wheel. The third and most complex part sits on the inside of the wheel. Let's go over to the lathe then and make some replacement parts. And I'm starting by making the most complicated part first, the spacer or disc that sits between the enclosure and the wheel. I'm using aluminium because I don't have any other material this size at hand. This workpiece is a leftover from an earlier episode when I repaired that Isla metal saw. Back then I had bought more stock than I required. And I start by reducing the outer diameter of the part. Don't be irritated by the off-center hole in the middle. That hole was simply not drilled correctly at an earlier time, and we will correct that in just a minute since we need a bigger hole there anyway. After having reduced the outer diameter already quite significantly, I drill out the hole in the center to the required size using the tailstock chuck. On the left is where we are now. On the right is where we want to be. I've taken measurements and drawn the wanted outer diameter onto the workpiece. We remove some more material and then we flip the piece around in order to get a much smaller outer diameter on this side, like with the original part. And after also chipping off the edges, our first replacement part is finished. For the second part, we can use this aluminium disc we found at one of the scrapyards. It is hemispherically shaped on one side, and we're cutting away a lot of material here to create a cylindrical form that will act as our new adapter for the inner diameter of the replacement wheel that I have bought to the shaft of the grinder. The wheel is a new old stock part, being just as old as the grinder. Now a center drill is inserted into the tailstock chuck, and after that a 10 and then a 12 mm drill bit. And then the outer diameter is again reduced, the edges are removed, and I actually had to widen the hole another time, this time to 14 millimeters, because I had remembered a wrong number there. The replacement parts are finished, and the new nut has arrived as well. But we still have to complete one of the wheel guards. For that, I have taken this leftover aluminium sheet from another project, and I have drawn the outlines of the other wheel guard onto it. I'm cutting it out with a jigsaw. By the way, whenever you see me using these battery-powered brand new tools, they are not mine. I share this space with a buddy of mine, and he has all those modern shiny things that I don't have, and yes, sometimes I borrow them for a couple of minutes. And I bent these little rectangular pieces here to a 90-degree angle in order to rivet a piece of aluminium flat stock to it. And this is where it will be installed. In the meantime, it was also necessary to make a new bottom plate and add a few finishing touches. But now it is time for a test. So as always, I hope that you liked this video and would like to ask you to give it a like if you want to see more of this content, telling me to go full steam ahead with more episodes like this one. If you want to support the channel, visit my Patreon under patreon.com/tpai, or maybe make a donation via PayPal. Links down in the video description. See you soon.